So we have a problem here on how to get the pH of a salt. So calculate the pH of a 0.5 molar solution of KCN, given the KF for HCN as 5.8 times 10 to the negative 10. So we have here KCN dissociating to give us K plus and CN minus. So this comes from a strong base and this comes from a weak acid. So we're going to have a basic pH if we have a salt like this. So from 0.5, okay, this will dissociate to give you the same amount of the ions to make it up. Now, out of this, the conjugate base of a weak acid will hydrolyze with water to give you HCN and OH minus, and you have here what we call the KB because you have a hydroxide. So if you're going to look at this, is the same amount as you have the 0.5 molar. So you don't have anything here initially. Then you have minus X plus X plus X. So you have here 0.5 minus X, and then you have X and X. So this is a KB, okay? Equals to HCN times OH minus over CN minus. Now we don't have KB, but we have Ka. So we know KB is equals to KW over Ka. So we can replace that 1 times 10 to the negative 14 over 5.8 times 10 to the negative 10. Okay, and then we replace it here with this value. Now, when we get the amount that is equivalent here is around 1.7 times 10, okay, to the negative 5, and it goes to x squared over 0.5 because we said 0.5 minus x is just equals to 0.5. So if we're going to cross multiply the two and get the square root, we can get the value of x. And x is equals to what? The hydroxide. So based on this one, x here is equals to 2.9 times 10 to the negative 3. So this is equals to your hydroxide. So from that, we can get the POH, which is just the negative log of 2.9 times 10 to the negative 3. And you will get them around what? 2.54, if I'm not mistaken. Okay, and we get pH, that's just 14 minus 2.54. So you have around 11.46. And as you could see, 11.46 is a basic pH, which makes our assumption that for a salt like this is going to have a basic pH.